Lodge Fenton, and I'll be guiding you through City and Guilds mathematics. For today's lesson, we'll be focusing on operations on common fractions. Let's begin. So from the stage 2 syllabus, we'll be looking at operations on common fractions. After engaging with this unit 1, I'd like you at the end of this to understand how to work with common fractions, to find a fraction of a quantity, looking at equivalent fractions, and add and subtract simple fractions. At the end of this session, however, you'll be able to use equivalent common fractions and add and subtract simple common fractions. From the stage 3 curriculum, we also will be looking at operations on common fractions. And with this engagement, you should be able to work on common fractions, including using a combination of operations as you work with these fractions. At the end of the session, you should be able to apply the operations of addition and subtraction to common fractions, not involving borrowing. When we talk about borrowing, we're talking about not involving regrouping a whole into fractional representation. All right, so let's review a little. What is a fraction? A fraction is a number, so that's the first thing. A fraction is a number that describes a relationship between a part, represented by the numerator, and a whole, which is represented by the denominator. If you look on the screen, you'll see a symbolic representation of a fraction, the 3/5. So you have 3 being the numerator. The fraction bar separates the numerator and the denominator, and the denominator is 5. Below that, you see a illustration, or we call a pictorial representation. It's an area model of what a fraction is. So 3 out of 5 parts have been highlighted or shaded in this particular representation. So let us review the types of models that can be used to represent a fractional portion. You can use the area model, like what we just spoke about. You can use your linear model, which is, as you can see, a line, what you call it again? A number line. There you go, on a number line. As you can see, it's between 0 and 1 there. So you see a quarter, a half, three quarters, and then you go to the 1. Then you have your set model. Your set model, which several things come together to make a set, and a portion of it, a part of it, is highlighted. So 3/10 of the apples have worm. So those are ways in which you can represent fractions. Now for today's lesson, we're looking at equivalent fractions. Let us look at what equivalents mean. The term equivalents mean equal, interchangeable in value or quantity. All right? That means when we work with equivalent fractions, we work with fractions that represent the same quantity or value, even if the numerator and the denominator are not the same. All right? And I just said that. So let's look at some examples of equivalent fractions. So equivalent fractions, fractions that name the same amount, are called equivalent fractions. Let us look at the diagrams here. So we have a half, 2/4, 3/6, 4/8. Now, just from looking at the pictorial representation, which is at the top, you realize that the shaded region is the same. How you speak about it or how you name it as a fraction changes. So now let's look at what is happening. So the first whole is divided into 2 equal parts, giving you a half is shaded. The second whole is divided into 4 equal parts. 2 out of those 4 parts are shaded. So 2/4 is equivalent to a half. The third diagram has the whole divided into 6 equal parts. 3 of those parts are shaded, giving you 3/6. So a half is also equivalent to 3/6 and to 2/4. Then you have the last diagram. Your fourth diagram is divided into 8 parts. That means 4 of those 8 parts have been shaded. You have 4/8 is equivalent to 3/6, 2/4, and a half. Awesome. So that's just looking at equivalence of a fraction. And we looked at the diagram there. So now let's look again. So we have, this is now rectangular shapes, and they're giving you both the symbolic representation up top and around the border of it, I should say, and then you have those diagrams. So you have a third. That means when you have a third, it simply means that your whole is divided into 3 equal parts. As said in previously, the denominator tells you how many parts the whole has been divided into. So a third tells you your whole is in 3 parts. Awesome. Then now look at the next diagram below that one. The whole is divided into 6 parts. The third is still represented here. However, because the division is now 6 parts, it's 2/6 of the whole, which is equivalent to a third. Then you have the last diagram is divided into 12 parts, and 4 of those 12 parts is shaded green, or are shaded green. And now you have 4/12. 4/12 is equivalent to 2/6, and it is also equivalent to a third. Now, as you can see from the blue, you have a whole which is not divided into any parts, so it's 1 out of 1. Then you have a whole divided into 2 parts. 2 out of 2 would give you that same whole. Then you could divide a whole into 3, 4, 5, 6, 8, 10 parts. All this is saying a whole is a whole. It doesn't matter how many parts you want to divide a whole in, it still represents a whole. Now, when you look at this fraction wall, you can pretty much pick out some equivalent fractions. So let's look at a half. If you look where that half line is, what other fractional part can represent a half? So you want to go straight down with your finger and you want to look at it. So 2/4. So 2/4 is equivalent to a half. And if you were to continue down, 1, 2, 3, 3/6 is equivalent to a half. That line is the same. Remember, it's the same whole. Then you look at 8s. 1, 2, 3, 4. 4/8 is still a half. 1, 2, 3, 4, 5. 5/10 is still a half. So if you were to look at a fraction wall, if you're not so, versed with equivalent fractions, if you look at simple unit fractions, you can easily pick up where you'd have some amount of equivalence. Let's look at a third here. Let's see if anything equivalent to a third. So if you carry your finger down, you see that 2/6 will give you a third. All right, awesome. And if you were to look at fifths, so 1/5, 1/5 is the same as 2/10. And once the lines don't line up, they're not equivalent. So that's just one way in which you can look at, you could try to figure out what fractions are equivalent. Now let us go into today's work. So let us explore how to find equivalent fractions. If you have a half, we just did one with the fraction wall, but how do you find equivalent fractions to a half? Let's say you don't have a fraction wall, what you do? So we can either increase the number of parts, as we did, or in the whole, or we can decrease the number of parts. But I don't think you can divide it in anything less than 2. So in this case, we're going to increase it. All right, awesome. So here we have a half, and I'm using a pictorial representation as well as a symbolic one. So a half, and now if I were to divide each half into 2 parts, I would get 4 parts, making 2/4 or 2/4 equivalent to a half. If I did a further division, or if I go right back up to my halves and divide each half into 4 equal parts, I'd end up with 8 parts. That means 4 out of those 8 parts is still a half. Now here is a shorter way that, because at this level, you're not going to be drawing diagrams every day. You want to move to the next level. So when we are making more of something, when we were doing simple numbers, you would look at multiplication. Multiplication means to make more. So if you say you have a half, and you want to find an equivalent fraction to a half, you definitely could multiply it by a number. But it is important to know why you're multiplying. If I have 2 parts, so if I have a whole, I'm going to give you a pictorial again. So if I have a whole, and I've divided my whole into 2 equal parts, please note, not drawn to scale. So I divide my whole into 2 equal parts. and I want to now find an equivalent fraction, I can simply divide this part or make it 3 parts here and 3 parts here. So pretty much I now have 1, 2, 3, 4, 5, 6 parts. And if I wanted to incorporate that, I'm now looking at half of it. I still look at half, but now it's divided into 6 parts, so I'm looking at 3 out of 6 parts. Let's look at what I've done here. So I'm multiplying my halves by 3. I've made each half into 3. I'm multiplying by 3. So 3 times 1 is 3, and 3 twos is 6. Now I could have picked another number. I could have used, say, 5. Now it's key that you realize what's happening here. So 5 multiplied by 1 gives me 5. 5 multiplied by 2 gives me 10. So 5/10 is equivalent to a half. 3/6 is equivalent to a half. And I could have used 20. It doesn't matter once I am consistent with something. And we're going to look at that. So 20 times 1 is 20. 20 times 2 is 40. So 20, 40th, or 4th, yes, is equivalent to a half. So now let's look at this. I would have had to multiply both my denominator and my numerator by the same value. Because what it means that I'm cutting up, increasing the parts of the whole by a particular value. In this case, I've increased the parts of the whole by 3 here, by 3 there. So I've increased it by 5 here, 20 there. That means my whole is now divided into 6 parts. My whole is now divided into 10 parts. My whole is divided into 40 parts. That means each part is divided into 3 instead of the 1. So it is understanding that when you find an equivalent fraction, you are looking at a way to make the fraction either be divided into more parts or less parts. Let's continue. As we go, we'll explain some more. So here we go again. We can also divide the fraction to find an equivalent fraction to it. So let's go back to the board. If you look at the board, we have 5/10 here. If I were to divide 5/10 by 5, I would end up back with my half. So let's just do it up here because I don't want to take it for granted. I'm going to draw a line here so I separate there. So 5/10 divided by what I said? By 5. Right. I know you're accustomed to keep this and reciprocate, but as you can see, it's 5, 5. So if you reciprocate, you're going to get 5 over 5. So 5 divided into 5 gives me 1. 5 divided into 10 gives me 2. What I'm saying, you can either multiply to find the equivalent fraction, or you can either divide to find the equivalent fraction. And as you can see back here on the screen now, you have 1836 as a fraction. And if you divide both the numerator and the denominator by 3, it gives you an equivalent fraction of 6/12. If I further divide 6/12 by 6, I will get a half. So what we're saying, 1836 is equivalent to 6/12, and this is also equivalent to a half. All right. So this is just to summarize. We may multiply any non-zero number, multiply by any non-zero number, or we may divide by a factor of both the numerator and the denominator. So with the multiplication, it's pretty easy. You can pick a random number. But when you're dividing, you have to look at factors. For instance, let's look at the middle operation there. You have 12/16, and the method we're using here is division. So you're dividing by 4. 4 is a factor of 12 and 16. So let's see what number we could not have used. If you have 12/16, although 6 is a factor of 12, 6 is not a factor of 16. So you could not have found an equivalent fraction by dividing by 6, just to take note. All right, let's move on to an activity. So you know how it is already. I like to put it in a scenario that you can actually see how it is applicable in life. Your mom baked a pizza and divided it into 6 slices. It must be shared with you among you and your two siblings or between you and your two siblings. That means each gets 1/3. What fraction of the 6 slices is equivalent to 1/3? So I gave you the fraction with another divided in a different way. I divided the pizza into 3s. No, your mother cut it up into 6 slices. So you need to figure out what fraction of 6 slices is equivalent to 1/3. What do you do here? Let's go to the board, guys. So let's look at that quickly. So we say 1/3. So we have 1/3. We want to make it, so I'm going to just put equal here. We want to make it 6. So you need to familiarize yourself with numbers. What can be done to 3 to make it 6? Exactly. You can multiply it by 2. If I were to multiply 2 by 3 or 3 by 2, I would get 6. But please remember, whatever you do to the denominator must also be done to the numerator. So we also have to multiply that 1 by 2, giving us 2 6. So what we're saying, 2 of those slices is equivalent to 1/3. So if you get 2 slices, you would have eaten 1/3 of the pizza. All right. So we need to figure out what must be done to the thirds to make it 6. We did that. Awesome. So 2 6.